Hey guys, welcome back. So we're entering into a new unit. We're going to be talking a lot about probability, and we're going to start that conversation by going over a couple of things about factorials, permutations, and combinations. So these notes are on Google Classroom, and at the top, please make sure that you're filling in your name because I've seen a lot of submissions that say Dansby on them, which is what I'm writing in the notes because that's my name. But you have a name, so put your name, please, and also the date. I think today is the 26th because it's Sunday, and you can put whatever period you belong to. Okay, so to start this out, we're going to talk about something called the fundamental counting principle, which says that if decision M can be made M number of ways, so that's a number, it's a variable, and decision N can be made N ways, then the two decisions can be made M times N ways. So that's the rule that you should be following, and then we're going to apply that to some examples here. If you take a look at the notes, I've tried to enhance them a little bit to make it easier. First of all, to keep track of the date that the lesson was given and the notes were given. And also I've put like a thick border around the problems I want you guys to do for classwork. Okay, so we're gonna do 1 and 2 together and then 3 and 4 for you guys to try. The first question says, the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. So how many cones are possible if you can only choose 1 flavor and 1 topping? So the simplest way to say this is that you have 3 different decisions to make. You have to pick a cone, pick a flavor, and pick a topping. And the reason they're telling you that you can only choose 1 flavor and 1 topping is because they're trying to say like you can't get, multiple flavors and multiple toppings, because that would make this problem much more complicated. So what this is really just saying is that you take the 3 cones and multiply it by the 15 flavors and multiply that by the 8 toppings, and you're going to get a result here of 360. So this is saying that there are 360 different ways that you can combine these cones, flavors, and toppings, such that you have a different cone type, a different flavor, and a different topping in each of those combinations. The second question says, Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? Okay, so you kind of have to break this down. You're thinking about like the letter slots that are on a license plate, and so in the first 3 of those letters, it has to be, the first 3 spaces have to be letters, so letters of the alphabet, and then there are 4 more spaces after that, and those have to be digits, so single digits. So the way you can think about this is that if you're thinking about the letters of the alphabet, well, how many are there of those? There's 26. So the first letter is 1 of 26. The second one is a letter out of 26, and the third one is a letter out of 26. And then the last 4 digits, 4 spaces on the license plate are digits. So if you count the number of digits, there are 10 of them. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 10 possibilities. So that's going to be times 10, 10, 10, and 10. Why am I doing 26 3 times? Because I'm sure you're going to ask that question. And why am I doing 10 4 times? Because I have 3 different slots that these can all be different letters. And I have 4 slots where these can all be different digits. Okay, so if you multiply these together, that's going to take me a sec to punch in my calculator. Hold on. Okay, you get like a huge number. That's great. So there are... Oh my gosh. There are a lot of choices. So if you ever wondered that question of like, don't they ever run out of like license plate numbers? Well, I mean, if we have more than this many cars on our roads, well, I mean, this is Virginia, but if they had more than this many cars on the road in Virginia, they might have to figure out a different scheme or something and add a digit on or something. Okay, so check out 3 and 4. Go ahead and if you want to pause the video now and do them because we're on this thought process, go ahead and pause. Okay, so the next thing we're going to talk about is something called a factorial. You may have heard of this before. It's the exclamation point symbol. So it's some number and then an exclamation point will follow it, okay? And that is what a factorial is. I'm just going to roll this paper up so we can see everything. Okay, so let's see. The factorial tells us basically the product of all natural numbers that go from 1 up to n, okay? So let's say that you had an example like the first one, which is 9 factorial. So you don't say 9 exclamation point, you say 9 factorial. What this is that you take, actually you go from 9 and you count down. Actually, I have this reversed. So this is actually n to 1. So you start at n, which in this case is 9. So that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply all of that out, I'm going to just plug into my calculator. And I get 362,880. And that is what 9 factorial is equal to. And then if we do 12 factorial, it's 12 times 11 times 10 times 9 times 8, etc., etc., etc. And that's a huge number. It's looks like 4 million something. We can do 8 factorial. We get 40,320. Okay, this is a fraction. I'm not sure if maybe you're having a hard time reading this. This is 17 factorial divided by 11 factorial. Okay, so you would do 17 factorial on the top and then divide that by 11 factorial. And you get an answer of 8,910,720. Okay, the last example here is 0 factorial. So this is actually something that is just going to be equal to, let's see. It's just going to be equal to 1. Okay. So there's an asterisk here because 0 factorial is kind of like a special case and it always comes out to 1, okay? So just keep that in mind. All right, so if you're wondering how am I doing these so quickly with only a couple of button presses, if you have access to a graphing calculator, let me just make sure you can actually see this. Yeah. If you have access to a graphing calculator, the graphing calculator will do a lot of these functions we're about to cover for you. So instead of multiplying out 12 times 11 times 10 times 9, etc., you can just go to the calculator and you can put 12. And if you have a TI-84 or a TI-84 color, I think even the TI-83s is probably almost exactly the same. You're going to go to the math menu. That's the math button right here. And then you're going to scroll over to where it says prob for probability. And you're going to roll down to the factorial key. And it will calculate that for you. So you don't have to sit here and do 12 times 11 times 10 and so on and so on. All right. If you don't have a graphing calculator, that's okay because you can pull up the Desmos scientific calculator. So you should see on my screen right now, I've shared the Desmos screen with you. If you punch in the number you're trying to find the factorial for, so in this case 12, and then you go to the function tab right here, there is a factorial function key right here. You just enter that, and it already gives you the answer. You can also hit enter to go down to the next line, but the answer for that question is up here, and it matched what we got. So the Desmos Scientific Calculator is free, and the website that you go to for that is right up here in my address bar. It is desmos.com/scientific. You might want to bookmark that because we're going to be using the calculator quite a bit for these next couple problems. Okay, let's switch back. So let's do the next thing on the notes, which is actually where we're going to start talking about permutations. So a permutation is an arrangement of objects, or like where you line up some objects and do some counting, and the outcomes are dependent upon the order. So the order of what you're doing makes a difference. So the abbreviation for a permutation is NPR. And the first blanks you're going to fill out here this is where the order matters. We're also going to be talking about combinations next, and in combinations the order does not matter, and that's where the two things are different. So the formula to do a permutation is NPR equals n factorial on the top, and it's a big fraction. And then on the bottom you're going to do n minus r factorial, and that's it. Now there's also a calculator function to do this, so that will make these problems a lot faster. You won't have to use a formula, so you might want to try to figure that out. So the n in this formula, in this abbreviation for permutation, the n stands for the total number of objects that you have available to you in this set of information, and then r is the total number of objects that you use for the arrangement. So that will sort of start to make more sense as we do some examples. So let's go ahead and get some of those done. Let me just roll my page up here. So number 5 at the bottom here says, how many ways can you arrange the letters in the word dinosaur? Well, the first thing that you should be doing is looking and counting how many objects you have. We're talking about the letters that are in this word, and there are 8 letters in dinosaur. So the n value here is 8. And it's a permutation because the order of the objects matters. In other words, like when you place the D in dinosaur in the first slot, you can't place that anywhere else. It can't be used again. And then the next thing is the R value. The R is the number of objects to use for the arrangement. Well, I want to use all 8 of the objects because I'm going to place them into the arrangement of letters of this word. So that's going to just be 8p8, 8 permutation 8. And so what this comes out to is there's actually a shortcut for this. And the shortcut is that anytime the n and r are equal to each other, and actually I forgot to fill that in here, sorry. Anytime you have npn, meaning like these two small numbers in the subtext are the same, you can just do n factorial, and that's going to be your answer. So what we're doing here is we're going to just be doing 8 factorial, and I'm going to use my calculator to do this, and I think actually we did 8 factorial. Yeah, we did. We did 8 factorial up here as one of these examples, so I already have the answer. It's 40,320. Okay. Next problem. 7 students are competing in a geography B. Okay, so there's 7 students competing, and how many ways can they finish in the first, second, and third place? So you have to think about this in terms of how many students are there, or objects, and the number of students is 7, so this will be 7. It's a permutation. And the order matters because once a student has made first place, they're not going to show up again in this arrangement. So that's how I know it's a permutation. Now, there's only 3 slots that I care about, and so I'm going to put a 3 here as the number of objects to use for the arrangement. They didn't ask me what would the places be of all 7 students. They just wanted to know how many ways can they finish first, second, and third, or how many different combinations of those 7 students will be in the first, second, and third slots. So it's 7 permutation 3. So we will use the formula for this, and then in a moment I'm just going to show you how to do it on the calculator. So the formula says we do n factorial, well n is 7, so 7 factorial. And then in the denominator, we do n minus r, so r is 3, so 7 minus 3 factorial. And this simplifies to 7 factorial divided by 4 factorial. And I'm going to punch that in my calculator. 1 moment, please. 7 factorial divided by 4 factorial. Okay, and I get 210 as my final answer here. I should be boxing all of my answers. I don't know why I keep forgetting that. Okay, so on the calculator, you could fill in the formula and then use the factorial key, which we already kind of like went over a moment ago. There's also a function on the calculator that does permutations and combinations for you. So there's a little trick to it. So you have to make sure, depending on your particular calculator, you're entering the stuff correctly. So if you have a TI-84, a graphing calculator like this, or even a TI-83, I'm pretty sure the options are exactly the same. You're actually going to type the number that's n before you even put anything else in. So let's do this one in the calculator. We're going to do 7, right? That's the n value. And then we're going to go to the math menu. And I want to make sure you can see my full calculator here. So the math menu is right here. We're going to roll over to where it says probability. And then there's an option here to do NPR, which is permutation. So we're going to choose that. And notice what my calculator did. It might look a little different if you don't have an 84 plus color edition. But it still should work out the same. The n value went into the subscript automatically. So all I have to enter now is the value for r, which is 3, and hit enter. And it calculated for me that the answer for this is 210, which matched what we did for our formula. So you can trust that button. And I also want to show you how to do it on the Desmos calculator, because on the Desmos calculator, it is different. So let's go ahead and clear our screen here. If you go to the functions tab right here on the Desmos calculator at the bottom, there is an NPR button. You can click it first. And what's going to happen in the scientific Desmos calculator is it's going to give you parentheses automatically, and you're going to put in the n, put a comma, and then put the r value, okay? So the n value was 7, and then my r value was 3, and I'm just going to hit enter, and I get 210, which is matching everything else. So just make sure that you understand how to enter it in the calculator before you rely on the calculator. If you don't want to use this Desmos one, and you don't have a graphing calculator, and you're not sure how to use the combination or permutation or factorial on your calculator, please come to my Google Meet, even if it's only for 1 minute. Just show me your calculator, and we will just find the buttons for you. Even a quicker way could be just to go to YouTube and put in your calculator's model number and just search for permutation or combination, and I'm sure there's like a tutorial that will show you exactly how to do it. Okay, so we're going to turn the page on these notes, but let me flip back here on my video. Okay, so we are turning the page, and this is page 2 of the notes. Notice that page 2 is labeled for you at the top. I would like you to please enter your name on all pages. And you're probably like, why am I writing my name so much? Well, when I grade these things, and, my only thing I can rely on is looking at your handwriting. That's how I can tell who sent their picture of their work to somebody else. And when that happens, you both get zeros. So, why would you do that to yourself? And if you think I don't recognize your handwriting, you're totally wrong, because I 100% recognize handwriting and the differences in handwriting and what your particular handwriting looks like. I've been your teacher for almost the entirety of this school year, and so I know what your handwriting looks like at this point. Don't pull a fast one on me. Okay, so on the next page, the first problem says Melanie is taking 4 classes this semester: American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? So the question is, she has 4 classes, and the question really is how many like how many slots are in her schedule, because we know how many objects we have, we just don't know, exactly what the number of slots are that we can fit those objects and arrange those objects in. I'm gonna assume that we're gonna try and make this question simple and boil it down. So I'm gonna assume that Melanie just has 4 slots in her schedule, and there are 4 classes that she can take. So this is gonna be a 4 permutation of 4, which is just going to be 4 factorial, and 4 times 3 times 2 times 1 is 24. So there's 24 different ways in which Melanie can arrange these 4 classes into the 4 slots she has on her schedule. I know this is a permutation because when I'm looking and reading the information about this, it is clear to me that it doesn't make sense to me that there would be any repeats. Like, you wouldn't have American history in multiple places, okay, on the schedule. You'd only have it one time, okay? 8 and 9 are classwork problems. They have a thicker border around them. You can go ahead and do those. And the next thing is going to be 10, and then 11 is going to be for you. So number 10 says, how many different 10-letter arrangements are possible using the letters that are in the word automobile? So what we have here is a word, automobile, and how many letters are in this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, perfect. So there are 10 letters, and okay, so what's happening in this problem is that there are objects in the set that are repeating. So you're rearranging all the letters, but there's a special thing you have to do when an object is exactly the same, depending on how many times it is repeated inside of the problem. So let's look at the word automobile, and you can see that the letter O is repeated, so it's in there 2 times. It's still going to be so like, it doesn't say it has to be a real word, it's just an arrangement of the 10 letters, and there are 10 slots to put them in. So your combination is actually going to be 10p10, okay? And it matters the order. That's why it's a permutation, because you don't want any of the letters that have been used already to repeat, except you don't have that choice with O because it's in there twice. So what you have to do is, the thing that repeats, you actually just divide it by how many times it repeats as a factorial. So O repeats twice, okay, there's 2 of those. So that means we're going to be dividing by 2 factorial. There's no other repeat letters, so that's it. We're just going to divide this by 2 factorial. If you remember, when the n and r are the same, you just do n factorial, which is 10 factorial. So it's going to be 10 factorial divided by 2 factorial. I'm going to plug this into my calculator and get an answer. 2 factorial. Okay, so there's a lot of different possibilities here, but it looks to be 1,814,400 ways to do it, okay? Now, there's not really like a formula to remember for this. You just need to make sure that you're doing the permutation in the numerator, and you are dividing by the object that repeats, however many times it repeats, as a factorial. Because that's kind of tricky, I'm actually going to do 11 with you. How many different 9-letter arrangements are possible using the letters that are in the word disappear? So 1, 2, 3, 4, 5, 6, 7, 8. There's 9 letters. There are actually 2 repeats here. Okay, so A repeats and the letter P repeats. Okay, so pay attention to that. Okay, so A is going to be a 2 factorial, and P is going to be a 2 factorial. So on the numerator here, we're going to make our permutation. It's a permutation because the arrangement matters, the order matters, and there are 9 letters available, and 9 slots to put them in, okay? We're going to divide this by 2 factorial, 2 factorial. This one represents the A's that are repeated, and this one represents the P's that are repeated. So if you had a question that had a letter that was repeating 3 times, it would be 3 factorial, okay? Now, let's go ahead and solve this. You know what? Actually, I'm going to stop the problem here and let you do the answer, okay? So the formula is set up. You just need to go ahead and calculate that, all right? The next section, the last actual topic in this one is going to be about combinations. Combinations, it's a very similar situation where you have an N, and then instead of having a P there for permutation, you have a C for combination. In a combination, the grouping, the order does not matter. Okay. The formula to follow for this is n factorial, so it's really similar to the permutation formula, so just be careful, times r factorial, and then in parentheses n minus r factorial. Once again, there is a button on the calculator that does this for you, so pick your poison. I'm going to leave it up to you. If you have a situation where the n and r are the same, so it's n combination of n, what's happening is that answer there is just going to be 1. That is the answer, okay? So let's work on this. Natalie has 16 close friends. How many ways can she choose 5 of them to be bridesmaids in her wedding? Okay, so out of all of her 16 friends, she's going to find a combination of 5 of them. Okay, that's the easiest way to read that type of problem. And we can fill in the formula for this as 16 factorial, and we're going to divide that by 5 factorial, and then in parentheses 16 minus 5 factorial. Let's go ahead and simplify that. This is 5 factorial times 16 minus 5 is going to give me 11, so 11 factorial. And we're going to use our calculator to do this. And what's going to happen is we're going to have 4,368 different ways that she can choose 5 from that group of 16 to be her bridesmaids. Okay, I just realized you could not see anything I was writing on the document camera. Sorry about that. So I'm rolling this up. I think it was cut off like here-ish. So let's recap real quick. So here's the formula that we were using. And then here is a situation where if n and r are the same number, then the answer is going to be just 1. And then I worked out the first example using the formula. I'm going to do 13 and 14, so you can actually see me doing those too. There are 24 students in Kyle's kindergarten class. How many ways can he choose 8 of them to attend his birthday party? Well, there's 24 possible students, and we need to find a combination of 8 of them. And you can use the formula. I'm just going to use the combination function on my calculator because that's a lot faster. So there's 735,471 different ways that he can choose 8 of those 24 students to attend the party. Last question I'm going to do with you is about Abby. Abby is adopting kittens from the pet store. Fun fact, I just adopted a kitten 2 days ago, so that's cool. Abby is adopting a kitten from the pet store. If there are 18 kittens, in how many ways can she choose 2? So there are 18 altogether. We're looking for a combination of just 2 of them. So if I do 18 and then I do combination 2, there are 153 ways for her to choose. Okay. Sorry, I was just checking some math on something. All right. So 15 and 14 are for you guys. They are classwork. In addition to doing these classwork problems that are listed on the notes, I have created a Delta Math assignment that goes with this. Okay, so today, the day of this assignment being posted is Monday, April 27th. And on the following Monday, let me check my calendar, that's May 4th. So on May 4th, you need to have turned in these notes. There's 2 pages. You need to have taken the notes and completed the practice problems on here. And in addition to that, there's a Delta Math assignment due the same day. Okay. Good luck, you guys. And if you need any help, please come to my office hours. See you guys later. Bye-bye.